Hi everyone! Today I'll be presenting a recent Nature Cell Biology paper titled Lysosomal Surveillance Response to Stress Extends Health Span. This study uncovers a new stress-responsive program, the Lysosomal Surveillance Response, called LYSA, which boosts lysosomal function and promotes longevity in C. elegans. Lysosomes are cellular organelles that degrade macromolecules and recycle building blocks, maintaining homeostasis. When lysosomes malfunction, misfolded and aggregated proteins accumulate and accelerate aging and neurodegeneration. Acidification of lysosomes is driven by the vacuolar H plus ATPase and VATPase, a multi-subunit proton pump conserved across the species. And this is what you already know. And here's a picture. Now here's a key question. Can we activate the lysosome, like make it stronger, by slightly stressing the system? Could silencing certain VATPase subunit trigger an adaptive responses that enhance lysosomal function and extend lifespan? Okay. The authors use C. elegans, a model for studying aging. They silenced each VATPase subunit using RNA interference and measured lifespans, stress responses, and gene expression. And here's what they found. Silencing VHA6, 8, 14, 15, and 20 made worms live up to 70% longer, but knocking down VHA16 or VHA19 shortened lifespans dramatically. So not all stress is bad, some can be beneficial. And we can know that from this result. Transcriptome analysis revealed 760 genes uniquely regulated in the long-lived worm. These genes related to lysosomal activity, proteolysis, and innate immunity. The team named this program the Lysosomal Surveillance Response, or LYSA. It's like the cell saying, my lysosome is stressed, so let's make it stronger. They checked if LYSA was just a general stress response, but it wasn't. Markers for mitochondrial, ER, oxidative, or heat shock stresses were not activated. So LYSA is unique lysosome specific pathway. Interestingly, VHA6 RNAi extended lifespans even when the main longevity pathways were disabled, including insulin, IGF-1, mTOR AMPK, and dietary restriction. So LYSA defines a new route to longevity. And we can know that from this result. Promoter analysis of those 760 genes revealed a GATA motif. Among all GATA factors, most ELT2 was essential. Only ELT2 was essential. When ELT2 was knocked down, LYSA activation and lifespan expansion disappeared. Chromatin assays confirmed that ELT2 binds directly to lysosomal gene promoters like CPR5. In short, ELT2 is master switch of Lysa. To fully oh, to fully activate Lysa, ELT2 needs help from CBP1, the worm equivalent of human CBP P300. CBP1 increases H3K27 acetylation, loosening chromatin for ELT2 binding. Silencing CBP1 blocked lysogen induction and lifespan benefits. Together, CBP1 and ELT2 drive the LYSA program. So, under dietary restriction, LYSA markers like CPR5 also increased, but only about 6% of genes overlapped between DR and LYSA. So, LYSA and DR are related but distinct pathways. Interestingly, silencing ELT2 blocked DR's lifespan extension, suggesting DR partly used the LYSA route. Now, does LYSA really boost lysosome? Yes, in long-lived VHA6 worms, lysosome became more acidic and active. In VHA16 and 19 worms, acidity dropped and degeneration slowed. Although Paget markers confirmed improved cellular cleanup under LYSA. And we can know that from this table. Okay. LYSA not only extend lifespans, but also improve health span. In neurodegenerative models, LYSA reduced protein aggregates and improved worm mobility. It restored proteostasis, the balance of protein folding and clearance. So in summary, here's the overall model. Okay, VHA6 knockdown disrupts intestinal acidification. CBP1 acetylates chromatin and opens the DNA. ELT2 activates lysosomal gene, the LYSA program. Lysosomes clear protein wastes and extend health span. This reveals a lysosome-centered longevity mechanism. Instead of fixing damage, the cell prevents it by upgrading its cell cleanup system, targeting GATA vectors or CBP P300 would inspire future anti-aging therapies. Of course, this all was done on worms, so next we need to see if mammals have a similar CBP1 to ELT2 to LYSA axis. We also need to ensure boosting lysosomal activity is safe in long term. So thank you for listening to my speech. Bye bye.